Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Daniel from DLM5B. Today, my group and I will be presenting about air transport pollution contribute to the global. First of all, I will introduce all my group member, which is me, Daniel Faham, then Daniel Zakwan, Imran Mukris, Zairul Hakimi, and Shafiq Arshad. Okay, for the first topic, I will talk about the global carbon dioxide emission and fuel efficiency. First one is carbon dioxide will contribute to climate change, which carbon dioxide will corrode the ozone layer, which let the sun ray from being filtered, which this situation can increase the earth temperature, as the sun ray cannot be filtered as the ozone layer has not thick as before, because of the carbon dioxide has corroded the ozone layer. Next is anthropogenic emission, which anthropogenic emission is anthropogenic carbon emission, which are the emission of various forms of carbon, which this is the most concerning being carbon dioxide associated with human activities. These activities include the burning of fossil fuels, deforestation, land use changes, livestock fertilization, and etc., which this emission caused by the carbon dioxide emission by the burning fossil fuel by the airplane. So we can see that the airplane contribute to the CO2 emission than others emission. Next, I will talk about the fuel efficiency. Okay, first of all, I will talk about the two type of engine, which is the first one is the quad engine and the second one is the twin engine. According to both of type of engine, the quad engine is a form of 4 jet engine, and the twin engine will provide only 2 engine for an airplane to move and fly, which the quad engine will consume more fossil fuel, and the twin engine will only cost lesser fossil fuel to move the airplane, which the twin engine can be seen as more fuel efficient. Next is I will talk about the factor of fuel efficiency, which these are 4 factor, which is higher wing weight. Higher wing weight will cause the fuel efficiency, as if the wing located higher, the airplane need more thrust power to fly the airplane. So the next one is smaller engine fan diameter. If the fan diameter is smaller, the fuel emission is lower, which is it is more fuel efficient. And next is seating density. Seating density is when in an airplane the passenger seating, which is we call as seating density. So if there is more seating density, so the airplane will have to consume more fuel than the lesser seating density airplane. So if the seating density is increased, the airplane should consume more fossil fuel. The last one is passenger load. Passenger load can include from the baggage that came with the passenger. So there will be there will be a factor too for the airplane to have more fuel efficiency. If the passenger load is lesser, so the airplane will consume lesser fossil fuel to make the airplane move. That's all from me. Thank you.
Okay, Assalamualaikum. My name is Muhammad Shafiq Arshad. So today I will present about operational and regulatory constraint. air cargo current contribution to global emission. This influenced by both operational and regulatory constraints. Next is because lack of airport and ATC infrastructure. This may cause congestion and the additional fuel burn associated with holding in the air and on the ground. After that, due to military zone and other government restrictions, many routes are flown less directly than they could be. Next point is regulatory constraint. This may have impact on the type of operation the airline can provide in order to make the most efficient use of aircraft capacity and fuel and emissions. Next is air traffic right based on the bilateral agreement between two countries. This point is making it difficult to provide an air cargo service that combines traffic right from 3 or 4 countries. Last but not least is strictly bilateral basis. This will significantly reduce the average load factor achievable over the road by up to 20%. That's all from me. Okay, next I will pass to my friend.
Assalamualaikum warahmatullahi wabarakatuh. My name is Imran Muklis bin Hassan Musanif. My number ID is PDL20071010. Okay, so for my part is I'm going to explain about future global carbon monoxide emission scenario. Before we start, I'm going to explain what is carbon monoxide emission. Carbon monoxide emission are the primary driver of global climate change. It can linger in the atmosphere for thousands of years. So it is dangerous for humans. Yes, it can cause headache, dizziness, blurred vision or muscle weakness. So we go to the next slide. One example of carbon monoxide emission is condensation trails. Those white clouds that we see coming out from aircraft jet engine called condensation trails or contrails. Contrails form when hot air from jet engine mixed with low pressure cool air. So, condensation process happen and produce water vapor and serious radiative forcing. So the first one is produce water vapor. Water vapor condense and freeze in the air and create tiny ice crystal. This ice crystal create clouds layer which stay at the sky for a long period. Next is serious radiative forcing. Contrast also creating a thermal blanket known as serious radiative forcing. During daytime, this cloud layer will be blocking radiation from the sun and trap the heat. So this will be increasing the atmosphere temperature. Heat from contrast can be warm the atmosphere more than all the carbon monoxide released by airplane. So this is my last slide. My first point is scientists forecast that the effect of these contrails are expected to be in 2050 unless airline company and airplane manufacturer find effective way to reduce it. Until now, still there is no technology that can reduce and control this contrails effect because it happens naturally. Okay, then how to avoid this creating these contrails? The only things airline can do to avoid creating this contrail is the first one is air traffic controls, which is ATC, will instruct pilot to changing airplane altitude to mid-flight at contrails area usually happen. The next one is required to pay for emission whether by tax or cap and trade.
Assalamualaikum, my name is Daniel Zakwan and I'll be presenting about investment in greater fuel efficiency for the future. In today's world, most of air freight traffic are highly dominated by long-haul freighters. There is some area which were less dominated by short-haul freighters, in which they only operate during high priority shipment. To overcome this issue, airlines company can use hybrid aircraft, make a better economic measures, and change to aviation biofuel. Firstly, hybrid aircraft. A hybrid aircraft is an aircraft with a hybrid electric powertrain. The concept is inspired by the emission control system used in ground transportation vehicles. Many heavy-duty diesel trucks today house post-combustion emission control system to reduce carbon dioxide generated by engines. Today's planes are propelled by jet engines anchored beneath each wing. Each engine houses a gas turbine that powers a propeller to move the plane through the air as exhaust from the turbine flows out to the back. Due to this configuration, it has not been possible to use emission control devices, as they would interfere with the thrust produced by the engines. In the new hybrid electric or turbo-electric design, a plane source of power will still be a conventional gas turbine, but it will be integrated within the plane's cargo hold. Rather than directly powering propellers or fans, the gas turbine would drive a generator also in the hold to produce electricity, which would then electrically power the plane's wing-mounted electrically driven propellers or fans. The emissions produced by the gas turbine would be fed into an emission control system broadly similar to those in diesel vehicles, which would clean the exhaust before ejecting it into the atmosphere. Thus, it can significantly reduce or even completely remove carbon dioxide emission. Moreover, the maintenance cost may be reduced because it is cheaper. Secondly, better economic measures. Unlike ground vehicles, which don't need to be as fuel efficient because they can refuel often, long-distance aircraft must carry all the fuel on board. It is expensive, heavy, and takes up significant storage. Its weight limits the range of an aircraft, and it needs to be stored in tanks, which affect the wing size and reduce the maximum load. Each new generation of aircraft has double-digit fuel efficiency improvements, up to 20% more fuel efficient than the previous one. This has led to today's modern aircraft producing 80% less carbon dioxide per seat than the first jets in the 1950s. Fuel efficiency is critical to the future of the aviation industry, not just for environmental reasons, but also financial ones. Fuel makes up over 30% of airline operating costs. Newer aircraft like the Airbus A350 consume on average less than 3 liters per 100 passenger kilometers. This fuel is comparable to that of compact cars, although aircraft travel much further and faster. So, all airlines should buy new modern aircraft which are more efficient and more environment friendlier. And lastly, aviation biofuel. An aviation biofuel is a biofuel used to power aircraft and is said to be a sustainable aviation fuel. The International Air Transport Association considers it to be one of the key elements to reduce carbon footprint within the environmental impact of aviation. Aviation biofuel could help decarbonize medium and long-haul air travel, generating most emissions, and could extend the life of older aircraft types by lowering their carbon footprint. Biofuels are biomass-derived fuels from plants or waste. Depending on which type of biomass is used, they could lower carbon dioxide emission by 20 to 98% compared to conventional jet fuel. So it is a good replacement for the current aviation fuel, which are kerosene that contributes to greenhouse gas emission. All fossil fuels, including kerosene, release greenhouse gases like carbon monoxide. This is directly attributed to global warming. Moreover, kerosene is hard to recycle. Non-renewable oil like kerosene and used oil is difficult to recycle. Again, this isn't good for the environment. That's all. Thank you.
My name is Muhammad Zarahimi. So today I want to present about the air cargo network and industry fuel efficiency. The ability to suffer sufficient high frequency of service and large enough aircraft to be cost effective is crucial to schedule airline operation, because many origin and destination market do not generate sufficient volume for such operation. Airline combine various market to add hub airport. On passenger side, hubs are often served by feeder service with small aircraft. Convenience connections are provided to other short-haul and long-haul flights. On the other hand, cargo hubs tend to be fed by shorter haul truck service rather than the flight. For the lower cost unit of operating, trucks, and also the somewhat lower time sensitive of cargo in general, especially in Europe. Services are operated by airlines on an airport-to-airport basis by the truck instead of aircraft. Connection are provided, mostly from long-haul passenger and freight flight. The next point is cargo traffic. Is carried by the combination carriers that also carries passenger. The cargo specialists such as cargologs and the integrators such as FedEx, UPS, TNT, and DHL. The latter tend to choose hub airport that are not passenger hub and thus less congested. This is reduce the environmental impact from stacking and long-haul aircraft taxi times. The next point is feeding the hub by truck and flying the long-haul sectors by air. The operators are able to optimize their fuel efficiency. They tend to use the more fuel efficiency 8747-400F and MD-11F aircraft combined with much more fuel efficient trucks. The type of trucks used on this feeder service would generate just under 60 to 70 RTKS per US gallon, compared to 15 to 20 for a long-haul freighter aircraft and around 10 for a short-haul aircraft. So that's all from me. Thank you.